Hi everyone. We got cut off yesterday in the last couple of minutes of this lecture, so I just wanted to go over our last couple of slides. I was talking about barrier islands when I got cut off, so I don't know how much you actually heard, but a barrier island is an island that's created from deposited sediment that um, allows for a barrier between the ocean and then like what's probably a little brackish water, a little salty, a little wet. I mean, it's all wet, it's water. A little salty, a little fresh. So a tidal inlet is when you have a barrier island that has just a tiny little break in it, like right in here, that allows for water to come in during the tides, like in a high tide, and that leads to a lot of transfer of material, sediment, biomass, all kinds of stuff coming in and out of here. A mud flat is when you have a low tide and you have a little barrier island. You have this water that's trapped in here, and in a low tide, you'll start to see the silt and the sediment appear, and it becomes visible because the water is so low. And then a salt marsh, once again, is when you have a little lagoon or a little like um, uh, trapped water in between a barrier island and land and the ocean. And the salt marsh is a marsh. It's watery, but there's also a lot of plant life, and those plants are going to be able to withstand brackish water. Brackish water, that's a term I keep using, but it means that there's 1% salt. Okay, a Ria coast, Ria River, is when you have a, a river channel that has an outlet that comes right into the ocean. But unlike New Orleans, where we talked about the other day, New Orleans is built on a delta, so you have all this sediment that's been built up as it's been transported and deposited by the Mississippi River. So the Ria Coast is where you have a river inlet or outlet and the ocean, and there's really no sediment or depositional landform that you can see. It basically is just like a seamless movement from the channel to the ocean. So channel to ocean. So you wouldn't even like if you were riding along the river here, you wouldn't even notice as you suddenly like got pushed out into open ocean. There wouldn't be a landform there. And then a fjord coast looks very similar to the Ria coast. The difference is that the fjord is created from a glacier. So a fjord is created from a glacial valley. And a glacier is a gigantic frozen river. It erodes these huge U-shaped valleys. And if you have a glacier that once upon a time hit ran all the way down to the ocean, you'll see those in Alaska or in Norway or places like that. If the glacier melts and now you have a fresh water or brackish water inlet, it's the same where it's just like this seamless kind of movement from the river to the ocean. So the difference here is that this is created by a glacier and this is created by just a regular river channel. All right, so we're going to see climate change, or I mean, we see climate change, but we will continue to see climate change. And we're looking at a predicted 1 to 5 meter rise of water in the next 50 years. So that's ocean water. And what's going to happen is a whole lot of our coast is going to be submerged underwater. If you look at the tip of Florida right here, like that entire tip is just going to be gone. It's just going to disappear. It's going to submerge. And then all along the west coast of Florida over here, Louisiana. This is the foot of Louisiana. That's going to be gone. That's New Orleans. New Orleans is gone. And all this coastline going from Texas down to Mexico, the Yucatan Peninsula, that'll all be underwater. And that's just right here. Just imagine what it's going to look like in India. India has 1,200,000,000 people living in it. So what's going to happen when their coastline is submerged? What's going to happen to the coastline of China and to the coastline of Europe? So we're looking at some serious eco-migration in the next 50 years. Coral reefs are super cool, and I really hope that you watch the extra credit video that I told you guys to watch called Chasing Coral. Coral is an entire ecosystem. Coral is this um, is a living thing. It's a relationship that coral, which is carbonate secretion, well, coral is secreting the carbon, and then algae live inside that coral. That is, it would be easier if I had a picture, but basically, like these two things living together create a whole other living thing that we call coral. You find it in shallow water, and along our coral reefs, so along this coral and algae, the carbonate that's secreted by coral and the algae that lives off of that secretion, um, you have all of these fish and all of these different plants. They happen in the part of the ocean where there's a surplus of energy, just like in the Amazon or in the Congo or in Indonesia, where you have a surplus of the sun's energy and a surplus of fresh water. We have so much biodiversity. Well, the same thing is happening in the ocean. So, all along the low latitudes, we have this surplus of energy, and that leads to this just explosion of life. And that explosion of life sometimes is around a coral reef. So, what's happening is we are destroying our coral reefs in many different ways. One, ocean acidification. Two, the temperature of the ocean. Those are all leading to and the temperature of the ocean and acidification are directly related to each other. But both of those, in different ways and together, are contributing to the degradation of our coral. So, of that algae and that coral, basically, the algae is leaving the coral, and you no longer have the basis of this coral reef. So, all of these other plants and animals that live off the coral reef are finding themselves without a home, and the destruction of that ecosystem is just going to continue to change the pH balance of the ocean and the balance of the ecosystems in the ocean. So we have a couple different coral reefs. We have a fringing reef. That's a reef that's going to be attached to an island or to the land. So you might see a fringing reef kind of just fringing, hanging off of, attached to an island or to, a continent. A barrier reef, that's one that's going to be parallel to the coast. So, like the Great Barrier Reef, for example, in Australia, is parallel to the coast of Queensland in northern eastern Australia. And then an atoll is like an island of coral. So it would be an island of coral, or it would completely like surround an island. Those are different types of coral reefs. And if we were in class, I would show you planet Earth and all of the life that lives all along the coral reefs. So I really encourage you to watch that extra credit video, Chasing Coral. It's amazing. Okay, so a lot of people have built their homes along the coast, for one, and two, if we are going to see more and more water rise, we're going to have to stabilize our coasts at least a little bit. So some of the ways that we stabilize our coast, what we call coastal engineering, is riprap. Riprap is basically a pile of rocks, like literally a pile of rocks that absorbs the impact and absorbs a lot of the water that would come and erode a barrier island like this. And if you can tell, if you remember from our barrier islands a few slides ago, this is probably going to be a tidal inlet, right? Because it allows the the tide in right there. Okay, so riprap, pile of rocks. Artificial beach nourishment. That's, like ice plant. I was talking about ice plant the other day in class. Ice plant comes from South Africa, and it's a plant that grows very, very well in the sand. Its roots get into the sand here. It keeps this stable. That's just one example, but that's what it means by beach nourishment. It's basically building up a plant community along this beach and the kinds of plants that would be able to tolerate the salty air and maybe brackish water, but would help stabilize this whole landform. And then another way that we have attempted to engineer stop the erosion of our coasts. I mean, look at this. We have a freeway running right along the ocean. So a groin is it's a it is basically a wall that we build along the coast. And where's my arrow? So it's a wall that we build along the coast, and it stops that beach drift. So if you remember that littoral current, that littoral drift that happens right here with the swash and the backwash, what this does is it basically stops that beach drift from eroding too much of this material and eventually coming in and just breaking this highway apart. The difference between, so a jetty is the same thing. The difference is that the jetty is going to go out further. The jetty is going to make its way, and it's going to basically stick out into the longshore current or the longshore drift, and that way stop more erosion. A jetty is going to be more vulnerable, though, obviously, because it sticks out further in the ocean. So you get like a storm, you get, a gigantic wave or some seriously strong waves, and what's going to happen is this is going to break apart. So a groin and a jetty are the same thing. The jetty is just longer, and it's more vulnerable because it's longer. And there we go. There's a end quote for you all. That's from one of my favorite books, The Poisonwood Bible. If you guys have never read it, you should definitely read it at some point in your life. So don't try to make life a mathematics problem with yourself in the center and everything coming out equal. When you're good, bad things can happen to you, and if you're bad, you can still be lucky. That's something to think about as we are in social isolation. I used to know somebody named Holden My Groin. All right, I will post your exam tomorrow at class time, and you'll have 24 hours plus a little bit to finish it. So you'll have to turn it in by Friday at 12:30. So I'll post it tomorrow at 11, whatever your class time starts, 11:10, and then you'll have to turn it back into me at 12:30 on Friday, and you'll email it, or you can like send it by Google Doc or whatever. It's going to be short answer. All right, bye.